Hello everyone, welcome back to my channel. Today I am going to deep diving into one of the most important topics for pump engineers, that is centrifugal pump performance curve. Understanding this curve is essential for proper pump selection and operation. Let's break this down step by step. Looking at our main graph, you will see three distinct curves plotted against flow rate Q. The blue curve represents head measured in meters, the red curve shows power consumption in kilowatts, and the green curve displays efficiency as a percentage. Each curve tells us something crucial about pump behavior. Let's start with the head curve in blue. At zero flow rate, what we call the startup condition, the pump develops its maximum head of about 50 to 55 meters. As flow rate increases, the head gradually decreases. Why does this happen? At highest flow, fluid moves faster through the impeller and casing, causing higher frictional losses and reduce energy transfer per unit mass. This is why the head Q curve slope downward. It is a fundamental characteristic of the centrifugal pump. Now the power curve in red behaves quite differently. At zero flow rate, the power requirement is relatively small but not zero due to internal circulation and mechanical losses. As flow rate increases, power consumption increases steadily. This trend is explained by the hydraulic power relation. Power equals rho GQH by eta. Eta is here the efficiency. Even though head decreases with flow, the flow rate Q increases more strongly, so overall power rises. This is why the power Q curve slopes upwards. The green efficiency curve is the most interesting. It is a bell-shaped, peaking at what we call the best efficiency point or BEP. At very low rate, at very low flow rate, efficiency is poor due to recirculation losses. At very high flow rate, efficiency drops again due to frictional and turbulent losses. But there is a sweet spot, the BP, where efficiency reaches at maximum at around 75% here. At BP, flow is smooth through the impeller, and hydraulic and frictional and leakage losses are here minimum. This is where the pump operates most efficiently. Let's focus on orange dashed line marking our BEP at 120 cubic meters per hour here, and efficiency is 75%. This is not just where efficiency peaks, it is where head, power and efficiency are in the optimum balance. The BP is where the pump operates most efficiently with smooth and stable flow through the impeller. Operating left BP causes recirculation, vibration and overheating. Operating right of the BP can lead to cavitation, erosion and motor overload. So why does this matter in practice? Pumps should be selected and run close to BEP for three key reasons. First, high efficiency means lower energy cost. This saves money over the pump's lifetime. Second, long service life. Operating near BEP reduce wear and tear, minimize maintenance cost. And third, stable and reliable operation. You avoid the problem that come with operating too far from the design point. So industry's best practice recommends operating within the plus minus of 20% of BEP flow rate. This means it will acceptable performance where avoiding the problem of extreme operating condition. When select a pump, always ensure your required operating point falls within this optimal range around the BEP. And that is your complete guide to centrifugal pump performance curve. Remember, the blue head curves drops, the red power curves rise, and the green efficiency curve peaks at BEP. Understanding this relation is the key to proper pump engineering. Thanks for watching and don't forget to subscribe for more fluid mechanics content. Thank you.